All right, we are on example 4 for reflection, and the directions on this problem say reflect the rhombus over the x-axis, and this is a rhombus. It can also be called a parallelogram. All right, so we first want to remember our x-axis rule. All right, so that's kind of where you start. So our x-axis rule, that shows us that x is going to stay the same and the y value is going to change to its opposite. So x is the same, y becomes its opposite. So x is the same, opposite y, and that's the rule we're going to use for all of these. So I'm just going to draw an arrow. All right, so let's find A prime. So original point A is negative 6, 3. So we're going to keep the negative 6, and then 3 becomes its opposite. So A prime will be at negative 6, negative 3. B prime, negative 2, stays the same, and 3 becomes its opposite, which is negative 3. C prime, negative 3, the x value stays the same, and then this negative 3 is going to change to its opposite, so it becomes positive 3. And then negative 7, negative 3, D prime will be negative 7, positive 3. All right, so let's graph those. So negative 6, negative 3. That is A prime. And there's going to be a lot of overlapping on this one because this figure is in quadrant 2 and 3. B prime, negative 2, negative 3. Make sure you're labeling each one and have the prime symbol. C prime is at negative 3, 3, so left 3 and up 3. And D prime is at negative 7, positive 3. All right, so there's a lot of overlapping on this one. All right, now before we go to the next example, I want to go back to this slide because I skipped over it earlier, but I want to talk about how to do this without a graph. All right, so that's one thing that I haven't really shown you yet, is how to do this with a graph and without using the rule. So I'm going to show you on this example, and I know that the lines on the coordinate plane behind this figure are a light shade of blue, but you should still be able to see. So I'm going to choose a darker color to write with, and I'm going to show you when we look at this example, the one on the left is reflecting over the x-axis, and the one on the right is reflecting over the y-axis. So the x-axis is here, and then we have our two triangles. How do I tell which one was the original? Well, the top one is the original because it has points A, B, C, and the bottom one is the image, what we call an image, because it has A prime, B prime, C prime. And if I were to fold this in half right here on this x-axis, point B would line up with B prime, point C would line up with C prime, and A would line up with A prime. So how could I get this without using my rule, which we know is x opposite y? Well, what you do is you put your pencil on each point and you count how many hops it is from the current axis that you're flipping across and go the same amount of spaces on the other side of that axis. So look at point A. It is 1 hop away from the x-axis. So you would go 1 hop away on this side and draw your new point, and that's A prime. Point B is 1, 2, 3, 4 hops away from the x-axis, so you would do 4 on this side on the same direction. 1, 2, 3, 4. And there's B prime. C is 1, 2 hops away. C prime is 1, 2 hops away on this side. So they're equal distance from the axis that you were reflecting across. All right, think about the y-axis. This is our vertical axis here. Let me erase those lines that I didn't mean to mark. The vertical axis, if we were to fold it, point B and B prime would line up, A and A prime would line up, and then C and C prime. They would touch perfectly. So this time we're going to this vertical axis. So if I hop from point A to the y-axis, it's 1, 2 hops away. A prime is 1, 2 hops away as well. So for point B, you would hop 1, 2, 3, 4 hops to the y-axis. So do 4 on the other side. 1, 2, 3, 4. And that was where B prime should be. See, 1, 2, 3, 4, 5. And on this side it is 1, 2, 3, 4, 5 hops away as well. So that's kind of how you tell. You hop to the axis that you're flipping across. So let's go to this last example with the rectangle. And let's use that rule first. It tells us to reflect over the x-axis. So remember, that is our left to right, our horizontal axis. So we're going to hop to this one here, and then we're going to count as we go and then do the same amount on the other side to find the reflection. So I'm going to actually do the graphing first, and then I'm going to check it with my rule over here. So let's hop 1, 2 to the x-axis. A prime will be 1, 2 on this side. Draw your point, label it A prime. Let's do B. It is 1, 2 hops away from the x-axis, so we're going to do 1, 2 in the other direction, and that is B prime. C is 1. This one's kind of hard to see because the lines. Let me do D first. 1, 2, 3, 4, 5, 6, 7. So I'm going to go 1, 2, 3, 4, 5, 6, 7 on this side. So that means D prime is right there. So same over here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And your paper should be a lot more neater than mine because I'm having to use this tablet to write and it's a little difficult. And there's my new figure. It was flipped across the X, so it went from quadrant 4. Now it is in Q1, quadrant 1. All right, let's use our rule. Our rule is X stays the same and Y becomes its opposite. So let's check. So point A, 3, -2 becomes A prime, which will be 3, +2. And let's check that. Is A prime at 3, 2? And it is. Continue using that rule. 10, -2 becomes 10, +2. So write 10 up 2. Yes, it does. B prime. Point C, 10, -7. C prime becomes 10, +7. Write 10 up 7. Yes, it is. C prime. I'm going to put my apostrophe. And the last one, 3, -7. D prime becomes 3, +7. And write 3 up 7. Yes, it is. So notice that now all these are in quadrant 1. So both X and Y are both positive, where they started out in quadrant 4 where the X's were positive and the Y's were negative. All right, so now let's do that last 2 problems, and we're going to do it without a graph. All right, so go ahead and pause the video and use your rule and solve this one by yourself, and then when you're finished, watch the next video and go over it with me.